Okay, we're going to do some trig examples. We are going to do 1, 2, 3 trig examples, and then I'm going to show you a method called incomplete substitution. Okay, we've done some basic trig examples. Let's look at some more. All right, ideas. Cosine squared?
Oh.
Just cosine x? So then du is negative sine of x? Dx? Right? Okay there? Okay. So we have this right here. So we can say negative integral of 1 over u squared du. I know you see something. Hold your horses. 1 over u squared, I don't really like writing it like that. When I'm doing derivatives and antiderivatives, I like u to the negative second, right? What's the antiderivative of u to the negative second? Okay, so what we have is 1 over cosine of x plus c. Like maybe we have a rule for secant x. Did we get there? Was it strenuous? Not really. April, what did you see right after Trevor suggested u substitution?
Sine of cosine is tangent x, and then cosine 1 over cosine is secant x.
And the antiderivative of tangent x secant x is? Okay. Now, that required some getting a little bit creative with some trig identities. If you don't see it that way, trig substitution works just as nicely. Was it a little bit of more work? Yeah, maybe a little bit. But we still got there in a relatively quick manner. Okay? Sometimes math is nice because there's more than one way to get there. Okay? All right. Let's try another one. This one we don't really know. Turn to your neighbor and give them a suggestion on how you think we should start the problem. All right, 5-4. Thoughts? Yep, that's good.
We decided to make u 1 plus sine x because it's inside of
the radical?
Yeah.
Okay, so under the radical is 1 plus sine of x. If we let u equal 1 plus sine of x, then du is? Oh, that is so nice, isn't it? We don't even have to, like, mingle anything. It's just straight up there, right? No numbers left over, no negatives left over. We have the integral of u to the 1/2 du. antiderivative of u to the 1/2. Caleb.
Um, 2/3.
So what we have is 2/3, 1 plus sine of x to the 3/2 plus c. Yes, sir.
So for like the test and stuff, do you want us to like put our comment messages just like that, or do you want like dy dx equals?
Well, it's not dy dx, so I would not want you to
Oh.
write dy dx. I'm fine with you doing it how I have it there. I mean, technically what it is the integral of cosine of x, radical 1 plus sine of x dx equals that. I don't think you want to rewrite that. All right, one more trig function one. Are you guys starting to get better at recognizing when and how to use u substitution? I'm hitting the rhythm. All right, CJ, is this a u substitution problem?
Yes.
And what would u equal?
X squared.
Okay, x squared is inside of sine, and conveniently we have one less power on the outside, right? Okay, I'm hoping you recognize that. So u is x squared, du is 2x dx. All right, we have x dx. That 2 is extra, so we need to divide it over, which means this becomes 1/2 the integral of sine of u du. Ashley, what is the antiderivative of sine of u? Good. So we have negative 1/2 cosine of x squared plus c. Yes.
Can I go to the bathroom?
I would suggest waiting until we're done, if you can.
How long is it?
I have 2 examples. Okay, now, I told you guys it was going to get a little more intense today, right? You're wondering when that is going to happen. It is now going to happen, okay? We're going to go through 2 examples of what I call incomplete substitution, okay? Go ahead and write this down as far as the example. But sometimes we have an x left over. So, if you saw this problem, you would think, oh, it's a composition and it has, 2 functions that are multiplied, one's a composition. So we typically like to say, okay, inside my radical is 2x minus 1. So that's what I'll put for u, which would make du 2dx. What's the problem?
There's no sense.
We have this x left over. This is called incomplete substitution. We have something left over, okay? But we know something about x, don't we? We know that u equals 2x minus 1. Which means if we rearrange this, u plus 1 equals 2x. So x is u plus 1 divided by 2. All right, I don't see a 2 out front, so we will have to do 1/2 du equals dx if you need to write that down. But what we're going to do is we are going to rewrite this integral as so. We have 1/2 the integral because of that 2. X is really u plus 1 over 2. And then we have u to the 1/2 du. Okay, so x was left over, so we just use our substitution to substitute in terms of u. And then like normal, we have our u to the 1/2. Okay, so now what we're going to do is we're going to write our u's using the power rule so we can take the antiderivative. So this is my suggestion to you. We have like a 1/2 right here, right? Let's pull it out in front. Constants I like in front of antiderivatives. So let's make this 1/4, and then we can distribute that u to the 1/2 through. So we have u to the 3/2 plus u to the 1/2 du. So that 2 I pulled to the outside to make 1/4, and then I distributed through, so now we can use the power rule. Okay, so now what we have, u goes to the 5/2 times 2/5 plus u goes to the 3/2 times 2/3 plus c. Okay, now just like normal, our original function was in terms of x, so we need to get it back that way. So this becomes, I'm going to go ahead and distribute this 1/4 as well. So this becomes 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. Am I crazy? Essentially, we had an x left over in our integral, so we rearranged u to substitute in terms of u. Go ahead and write this one down. Okay, so obviously we have a composition here. There's no way for us to rewrite this and do any sort of power rule. So use substitution is the only option we have to try. All right. What would you choose for u in this substitution problem? X plus 4 is inside the radical. That would be our best choice. Okay. Now this makes it nice. Du is dx. However, we have that 2x plus 1 in the numerator. That's okay because we have a relationship with u and x where we can rewrite it in terms of u. Okay? So if u is x plus 4, we know that u minus 4 is x. All right, so we can use that to rewrite our integral. That's what we're going to do here. All right? So 2x plus 1 is going to become 2 times u minus 4 plus 1. And since all we really have is the power rule with antiderivatives, I'm going to go ahead and rewrite it as u to the negative 1/2 as I make my substitution instead of writing it as over the square root of 2/3. Is everyone okay with that? Okay, but notice how I put the numerator in parentheses, because when we bring that up, it is being multiplied to the entire numerator. Yes. Yes, and we will do that, okay? So, yes, our numerator is 2u minus 7. And then even a step further, we need to multiply that all out so we can use the power rule. So we would want to write this as 2u to the 1/2 minus 7u to the negative 1/2. Good morning. Is everyone okay with where we are before we actually go to the antiderivative? Okay. So now we have 2 times u to the 3/2 times 2/3 minus 7 times u to the 1/2 times 2. So when we rewrite this to make it look pretty, we have 4/3 x plus 4 to the 3/2 minus 14 times x plus 4 to the 1/2 plus c. Yeah.
I know that.
Thoughts? Okay, they're interesting, right? You need to get used to them, all right? So you need to make sure that you practice them. Luckily, we have like more than 10 minutes left in class. I think we can start our assignment before we leave, which I think would be a good idea. But you do really need to get the practice of incomplete substitution just because it's a little bit different than normal substitution, okay? So you have a book assignment. I think you'll get to practice some trig 1. But we flip back to 301. I know that we've been kind of flip-flopping all the way through our book, but remember the, like last night's assignment was back in chapter 5. Did you notice that? That's because for some reason our book puts natural law, logarithmic and exponential functions in an entire separate chapter, but we like them with everything else. So now we're back to the real 4.5. And it does not look like your assignment is very long. Bold problems, 3, 6, 7 of them, and then 4 unbolded problems if you want that extra practice. So let's get to it.